CloudDB, shaping your new normal.
Welcome everyone to this session, Migrate Databases with Minimal Downtime using Migration Workbench that is part of Enterprise Manager product. My name is Harish Niddagatta. I'm based out of San Francisco, United States. I'm the product manager for database lifecycle management and database migration workbench areas. So in today's agenda, I'll start off by talking about why you have requirements to migrate and how Enterprise Manager's Migration Workbench caters to these different needs. I'll walk you through various Migration Workbench capabilities. We'll spend a few minutes on migration to cloud, followed by migration to new destinations. And we'll wrap up the session with a demo in the end. Earlier this year, we released the latest version of Enterprise Manager, which is called Release 13.5. We have several new features in this release. It's in areas like database lifecycle management. There is new user interface, UI for database patching and upgrades, new capabilities in hybrid cloud management, ops automation, and extensibility areas. Let's look at hybrid cloud management in a bit more detail so that this helps in solving challenges tied to database migration. With the new release of Enterprise Manager, you can now manage targets running anywhere, whether it's on-premise or in cloud. You don't need to learn or deploy new tools. Your existing best practices or scripts and jobs that exist can be applied to cloud resources, just like on-prem resources. Specifically for Oracle Cloud Infrastructure resources, Enterprise Manager understands the native service API for management operations, and it leverages to provide a seamless experience. If you are using or considering using Oracle Cloud databases like Autonomous Database or Exadata Cloud Service or Exadata Cloud at Customer, you can manage all those with one management tool, which is Enterprise Manager, in addition to managing on-prem assets with the same instance of Enterprise Manager. Enterprise Manager Hybrid Database as a Service supports deployment across on-premises and Oracle Cloud infrastructures, whether it's compute, ExaCC or ExaCS, and self-service governance tools for effective cloud resource utilization. There is a feature called Cloud Bridge. This Cloud Bridge feature of Enterprise Manager connects Enterprise Manager to OCI. The bridge is used to copy data from Enterprise Manager repository and the targets it manages to OCI object store, where it is accessed by OCI services like logging analytics and operational insights that provide deep analytics and identify data patterns, which can help prevent outages and achieve better application and database performance. Database Migration Workbench allows DBAs to plan a migration from on-premise to cloud and also from on-premise to on-premises. It performs all the prerequisite checks required on the source database. It selects the best data movement technology, whether it's data pump or TTS methods, based on the source and the target choices. It manages the execution of the migration. And then once the migration is successfully complete, it validates the results of the migrated database to make sure it is as performant as it was on the source database. So that's a perfect segue for us to look at database migration workbench in more detail. To begin with, let's look at why you need to migrate. Depending on your data center and your IT strategy, there are three different reasons to migrate. One is you want to migrate to Oracle Cloud, or you want to migrate your existing workloads running in a single instance databases to multi-tenant, or you're looking to re-platform your infrastructure. Let's look at your plans to migrate your workload to cloud. If you decide to migrate applications to cloud, you typically migrate its entire stack. Why do you do that? You intend to migrate the entire stack to the cloud primarily because over a period of time, you'd have done large number of fine-tuning of databases to make sure your applications are running per your requirements. So as a result of that, the dependencies between applications and databases increase multifold. You may have a requirement to migrate to autonomous or database cloud service or Exadata cloud services at customer environment. So you need a tool that identifies various database components to migrate to autonomous or to other cloud services provided by Oracle. Second need is your intent to consolidate your single instance databases to pluggable databases. For few years now, you would have deployed thousands of single instance databases or rack databases across your on-prem data centers. And today you're at a point wherein you're looking to leverage all the benefits of multi-tenant, be it the consolidation or ease of management or your IT's decision to go pluggable. So you need a tool that can help you migrate your single instance databases or rack databases to multi-tenant in a seamless manner. And finally, the third reason for migrating is if you're upgrading your infrastructure from legacy to new generation systems, or you intend to consolidate to new engineered systems. Again, for years, you would have deployed and expanded your database ecosystem across multiple commodity servers, or you may be managing these databases on very old engineered systems. Now, you're at a point of refreshing the infrastructure, whether to consolidate all your workloads onto the new generation of Exadata engineered systems, or just upgrading your existing old Exadata systems. And Database Migration Workbench enables you to seamlessly migrate your databases to the destination for any of these three reasons. Primary goal of this migration workbench tool is to reduce the overall operating cost by consolidating databases or data centers, while also giving you one tool for all kinds of migration. Migration Workbench is part of Enterprise Manager System Management tool. Enterprise Manager is a single tool for provisioning databases on private and public cloud. You can do complete lifecycle management of databases at scale. You can patch all types of databases at scale. You can also upgrade all databases at scale. You can secure the configuration of databases and hosts and monitor for any vulnerabilities. And you can migrate databases within a data center or from data center to cloud. And the cloud integration in Enterprise Manager enables you to manage cloud targets. Now let's look at Migration Workbench in more detail. Migrating databases using Migration Workbench is a simple, intuitive process that will guide you through setting up and moving your on-premises databases to Oracle Autonomous Database or to on-premises or to ExaCC or ExaCS. There are tangible benefits in using Migration Workbench. One, it simplifies migration of all on-premise databases to OCI, on-premises, DBCS with unified guided workflow. Two, it expedites the migration process by automating end-to-end workflow. Three, it reduces the downtime by providing real-time progress of the migration. And four, it improves the accuracy of migrations by providing an automatic comparison of performance before and after migration. With this tool, you can migrate databases from 11.204 onwards, be it single instance, rack, or multi-tenant. You can migrate to various destinations, on-premise to on-premise, commodity hardware to Exadata engineered systems, to Exadata cloud at customer, to Exadata cloud service, and to autonomous databases. All these can be done with various migration methods like data pump, transportable table space, plug and unplug, pluggable databases, and via standby. And you can do all these things on various platforms, whether it's AIX, Oracle Solaris, Oracle Linux, and also Windows platform. The key goal for us is to give you a tool with unified experience, whether you choose to migrate to cloud or choose to migrate on-premises databases to on-premises destinations. And we give you the flexibility to choose the migration option you desire. And all these things can be done with just one tool, which we call it as Migration Workbench. Now that you know the benefits of Migration Workbench and also various destinations and migration methods, let's look at the tool in a little more detail. The migration workflow here depicts end-to-end process. The dark green box indicates required steps you need to take to migrate a database. And light green box indicates optional customization that you can do for migrating a database. And all this optional customization can be done within the Workbench tool itself. You can add pre and post scripts as part of this customization, and these custom scripts will get executed as part of this end-to-end workflow, all within the Migration Workbench tool. You can look at Migration Workbench as three intuitive steps: plan, migrate, analyze post-migration. In the first step, which is basically planning phase, the guided wizard provides a unified migration experience for all types of migrations. With this, you can do consolidation estimation, you can do dependency analysis. With built-in schema advisor, you can analyze databases before migration. You can estimate size of destination database based on workload in the source database. In the second step, where you are migrating, Enterprise Manager Orchestration Engine allows you to customize, schedule, pause, or resume migration process at any time. You can monitor the progress of migrations in real time, and it receives and you can receive the notifications on status changes. If there are any intermittent issues during migration, you are given the flexibility to pause the migration, and you can resume after correcting the issue, as opposed to restarting the entire migration process. You can leverage REST APIs to automate end-to-end migration, and you can also integrate with third-party orchestration tools. Finally, the step 3, where you get to analyze the databases for desired performance. You will get an insight into objects that need attention and objects that are migrated successfully. Performance analysis gives insight into various performance comparisons before and after migration using proven technologies like SQL Performance Analyzer, SPA is what we call it. So these are 3 simple intuitive steps to migrate your databases. Let's look at each of these steps in greater detail now. Database guided workbench. This is part of step 1, which is the plan phase. Workbench gives you one-stop dashboard for creating a migration plan, customize any migrations, track migration process in real time. You will have the ability to act while migration is in works. You can do things like pause the migration activity, roll back, or cancel the entire workflow. This dashboard also gives you a summary of existing migrations. Summary, as you can see in the screenshot here, it gives you a summary of successful, failed, or scheduled migrations. It maintains historical data to diagnose and track migrations in the last 7 days. You can include pre and post custom scripts that get executed as part of the migration workbench, as I had mentioned earlier. Continuing on step 1, once a plan is in place, it runs an existing schema and gives you a summary status that includes objects that cannot be migrated due to certain restrictions or lockdowns, some database options in the source database may not be applicable to the destination database. The summary also calls out objects that will migrate with certain corrective actions. In addition, it will also list out automated corrective actions for you to act on. Schema Advisor report, the screenshot that you see here, clearly groups objects based on its findings whether objects cannot be migrated or migrated with changes. Now let's look at step 2, which is the migrate phase. For example, Workbench supports variety of destinations and migration methods. So for example, let's say you want to migrate database 12c to autonomous by leveraging data pump migration. Or if you are looking to migrate to new on-premise pluggable database using TTS migration methods. So you have these different migration methods available for migrating source databases to different types of destination databases. If you look at data pump as a migration method, data pump provides an export and import way of moving data and metadata from one database to another. You can export table data, database object metadata, and control information to a file. The file containing this data is loaded into the destination database as part of migration. Data pump supports two modes, full database mode or schema mode. In full database mode, the entire content of the source database is moved to the file dump and loaded into the target database. In a schema mode, only objects owned by the specified schema are moved to the file dump and loaded later onto the target database. There are multiple choices for you to migrate your databases. You could do it via UI, you could do it via CLI, or you could use the out-of-the-box REST APIs for any automation needs. And these REST APIs that are available out of the box can be used for easy integration with third-party tools. And also, Migration Workbench helps you to create and copy a pre-filled JSON file to integrate with any of your choice of third-party tools. Now, the final step is analyze. As part of the database migration from the Workbench, you can do step-by-step analysis of migration. You can drill down to the object level, identify and review those that have failed and passed. And for failed object, you can get more insights and the reasons for the failure. You can review completed migrations to verify any errors or warnings. When satisfied with the migration results, you can mark these migrations as complete. One of the key requirements for you as an end user is to ensure the migrated database at a minimum is as performant as it was while on the source platform. This is basically to make sure that you don't end up with a performance degraded database in the destination post migration. So typical steps for performance analysis are: you run SQL performance analyzer on the source, you capture the performance info, you migrate the database, run SQL performance analyzer on the migrated database, and analyze the performance. These are the typical steps you would take to do the performance analysis of the source database and the destination database or the migrated database. All these steps are done automatically within Migration Workbench. There is, for you as an administrator, there is no need for any manual intervention during this migration process. SQL Performance Analyzer will help you review and help you correct any SQL performance issues. Workbench provides a report that shows the net performance, and it will help you fine tune the recommendations. As a result, you can remedy any negative outcome before end users are affected. You can automate this SPA report analysis by using the REST APIs too. Continuing on this analysis, SPA automatically collects SQL statements from the database cache and creates a set of SQL queries called SQL tuning set or STS. There are two options available for you to do this performance comparison, either production grade comparison or DevOps grade performance comparison. DevOps grade performance comparison is out-of-box solution where you don't need to do any preparation. If you have an AWR report, you build out STS on the fly. You can choose the number of days for which statements from AWR reports should be considered to build the STS. By default, we collect data for the last 7 days. When this option is selected, Database Migration Workbench scans through the AWR reports for top SQL statements for each day and builds unique STS. This method is simple and quick and can be used for migrations involving databases for dev test purposes. Alternatively, there is a production grade performance comparison. In this case, user has to enable SQL Performance Analyzer to collect SQL statements from the database cache on an ongoing basis. This allows the SPA to record each statement and related performance parameters. If the same SQL statement is run again and again, each time, only performance metrics for the statement are updated. This method is best suited for production workloads to accurately build a SQL tuning set, or STS, what we call it. So the STS built using this method accurately represents a SQL statement with a very high workload. Database Migration Workbench allows users to select the best STS created by this process. So these are the 3 steps to migrate your databases to the new destination. With Database Migration Workbench, you plan the workloads to be migrated with unified guided visit, migrate the workloads to the new destination, pause, resume, and monitor the migration progress, and finally, do performance analysis to make sure your migrated databases are performant. Now, let's look at 2 use cases to see how these 3 steps are applied for database migration. First one is migrating on-premise database to cloud. Workbench, as I mentioned earlier, supports migrating from on-premise to cloud. You can choose the source database, you choose the destination, you choose the migration method. Data pump is the migration method supported for migrating to autonomous. Once the migration process is initiated, you can monitor the progress. Post-migration, you can run the SPA to do the performance analysis, all in one user interface. The screenshot that you see here essentially depicts the source database informations, the credentials that you need to provide for both databases and the host for the source database, and then the destination database that you have chosen, which is in this case is the autonomous database, and provide database credentials, agent host credentials, and the service name. And data pump is the preferred migration method. So you choose that and you provide a source data pump directory along with other cloud specific informations like cloud storage URL and the bucket name and the OCI credentials. Now, one important thing that you want to remember here is you can encrypt the data pump directory where the files are created with the source database information, and so that way you're protecting the contents of that file. Workbench also supports migrating to new destinations. Let's look at those. With Enterprise Manager 13.5 release update 01, you can migrate on-premises to on-premise, on-premises to ExaCC, ExaCS, and also on-premise to database cloud services, both bare metal and virtual machines. You can migrate single instance and pluggable databases to the destination of your choice. As I said, using any vehicles, whether it's UI or CLI or SDPI. And you know, the reason why this on-premise to on-premise migration is very crucial is that if your organization is planning to migrate or consolidate to multi-tenant over the next couple of months, and if you're on single instance databases or rack databases, you can use this tool to migrate those databases to, say, Oracle database 19C multi-tenant databases. There are 3 ways for you to do it: data pump, transportable table space, and if at all you're trying to migrate a PDB or a pluggable from a source database to pluggable on a as a destination on a new hardware platform, you could use the unplug and plug capability to migrate those databases. Let's look at a couple of these methods in a little more detail. You can use data pump export import method for logical migration of non-CDB to a PDB. There is support for databases 11.204 onwards. You can choose to migrate only schemas or full databases. It also supports different character set compatibility, and data pump is the recommended method for databases of smaller sizes. If you want to, there is another method to use, which is called transportable table space with incremental R1 backups to minimize downtime. This is also widely used to migrate in a phased manner. Here too, Workbench supports databases 11.204 onwards. It supports cross-platform migration, which is a huge deal. And if at all, let's say you're on a AIX platform and you want to migrate to Exadata or you want to migrate to new Linux platform, TTS comes into play in a big way. It supports compatible character sets with minimal downtime. You can choose to migrate only table spaces, or you can migrate the entire databases. And this is typically recommended for migrating large databases, large size databases. To wrap, let's summarize the benefits of using Migration Workbench. Database Migration Workbench is one end-to-end tool that enables you to migrate your databases. You select your source database or even schema that you want to migrate. You analyze the source before migration. With unified guided workbench, choose the destination target, customize import and export along with pre and post custom scripts if it required. Do the performance comparison before migration. Do performance comparison after migration using SQL Performance Analyzer, which is integrated into Workbench to ensure your migrated database is performant as expected and is comparable to the source. Finally, you can migrate to various destination types, whether it's on-prem, migrating non-CDB to PDB, or you're replatforming, or you're trying to move to cloud like ExaCC, ExaCS, or autonomous. That's a very quick look into what Migration Workbench is capable of. Now it's demo time. In this demo, you will see migrating a source single instance database to a brand new pluggable. The workflow you will see is exactly the same for any migration targets. So here you go.
Hello everyone. Today, let us go through a demo of the Database Migration Workbench using Enterprise Manager Cloud Control 13C Release 5. To get started, let us log in. We can access the Migration Workbench from the Enterprise Migration and Consolidation menu. This brings up the Activities page of the Workbench. From this page, we can initiate a migration of our on-premises databases to Oracle Cloud, that is Autonomous Database, DBCS systems, ExaCC or ExaCS. We can also migrate databases as pluggable databases to Exadata or other commodity hardware on-premises. For today's demo, we will migrate an 18C database to a 19C pluggable database on-premises. We can choose to migrate the full database or selected schemas. We will migrate the full database. We select the source, the DB18C database. This is sales database is our 18C database. We then select the destination. Here we can either choose to migrate to a pre-existing pluggable database or create a new pluggable database. For existing database, we can search by target type, target name, or even by target properties such as department, location, etc. For this demo, we will create a new pluggable database using an existing container database. We enter the PDB details. Note that we also specify the data pump directory name and data pump directory path so that the directory object is created as part of the PDB creation process itself. For efficiency purposes, it is desirable to choose a directory that is shared with the source database host. This will avoid a step to copy over the data dump files from the source to destination. Next, we enter the mandatory inputs such as the source and destination credentials. We can choose to compare performance after migration. We choose the data pump directory here. The destination is defaulted from our previous inputs. For security reasons, the data dumps will be encrypted. Hence, we provide the encryption password to encrypt and decrypt the data in the export-import process. Next, we can customize the migration process. The Migration Workbench defaults the options based on the source, destination, and method of migration. In this case, data pump. As you can see, it has defaulted the contents, what to exclude, encryption options, etc. We can choose to migrate the databases in 2 steps, metadata only followed by data, or we can perform the entire process as a single step. Today, we will use the single step. The Migration Workbench implicitly adds options such as dump file format, file size, job name, log file name pattern, etc. The procedure activity details exposes this list to the user for diagnostic purposes. Power users can also add additional export-import options if they so desire. In order to compare performance, we can create a new SQL tuning set from AWR. By default, it uses the last 7 days of AWR data, and this number of days can be customized, or we can choose an existing STS. We can choose to run custom script before and or after migration. As mentioned earlier, we will use a shared location to avoid an additional file transfer from source to destination. Let us review the inputs provided so far. Looks all good. So submit. We can choose to schedule it for a later date or time, but we will go with an immediate option for today. The migration activity is successfully submitted. We can view the JSON that will be used for this process and even copy it for future use. For example, if we had chosen the 2-step method, that is metadata only first, followed by data, we could simply fine-tune this JSON, change the content to data only, and trigger the data migration from the REST API or EMCLI after ensuring the metadata export-import was successful. This would reduce the chance of user errors while going through the wizard for a second time. Similarly, let's suppose we had multiple other databases of a similar type. Then we could use this JSON, fine-tune it as appropriate, and schedule the migration activities from the REST APIs or EMCLI en masse. Now let's go back to the activities page. Now the activities page starts showing this submitted migration activity. It summarizes the migration activities up on top along with its status, and the detail shows the list of activities. From this list, we can now view the procedure details along with detailed output from the utilities. We can analyze the process, that is, view the detailed report of validations performed, as well as detailed report on export and import issues. The validation tab details all the checks that were performed prior to starting the migration. These are deep validations performed at the source and destination to ensure access, storage permissions, and availability, correctness of the export-import options. Recall that power users can add additional export-import options which don't get validated during the UI, but they will get validated as part of this process. The Migration Workbench ingests the data pump logs and data from its master table and renders the same in an easy-to-view format for the user. In this case, we see that export was 100% successful, but there seem to be some few issues in the import. The detail shows that it encountered issues due to some existing table spaces such as undo table space and temp table space. We can sign up on the same for now, not an issue. Finally, we can also review the SPA report and compare the performance of the newly created PDB with that of the source. As you can see, the Migration Workbench allows you to analyze the database migration from different dimensions, such as the process details itself, deep validations, data transfer analysis, and performance analysis. With this, I come to the end of today's demo. I hope this showcases the ease with which you can migrate databases without compromising on the critical tasks required for performing a successful migration. Thank you very much for watching this demo. Goodbye.
And that's a wrap on a high-level introduction to Migration Workbench and a demo to show you how and what the user experience will look like. And everything that you saw in the demo is exactly the same user experience for any kind of destinations that you choose. So essentially you have one unified guided interface for you to migrate to various types of destinations from various types of sources. There are a lot of relevant, useful information out there for you to get to know more details of what this Migration Workbench is capable of. And please take a look at it. And in case you have a follow-up question, feel free to reach out to me, or you could talk to your Oracle account team contact, and they'll be able to find me. And then I'm happy to have a more deep dive discussions with you as a follow-up. Thank you so much. Have a wonderful day. Thanks. Bye.
CloudDB, shaping your new normal.